Nice. So, welcome to this little award ceremony, and I hope everyone can hear me. And if you can't, just speak up. And of course, you can't answer that either if you can't, but hopefully someone can hear me. So, welcome to this little award ceremony where we'll look at the winning projects, the top 3 and the random winners as well. Or the random prize, I guess, not random winners, because the winners are all well-deserved, of course. So, these projects were also extremely awesome. I was impressed with how well you got through with this more like fuzzy topic compared to some of the others we've done. And the scaling oversight is, it's a hard topic. So it's great to see that people can execute it into something clear and something awesome. And some great Discord energy this weekend as well. That was very fun to follow along with the people who didn't abuse GPTA, but at least interacted with it in fun ways. And this is a great little path towards safe AI as well. And of course, thank you very much to our great judges. I was also a little part of the process there. But of course, Gabriel Regia was joining as a judge. So he was also a keynote speaker, and he's an independent researcher with modular research and does a lot of scaling oversight research. And Ruki Xiong, I hope that I pronounced that right, but he's a PhD student at UC Berkeley under some wonderful alignment researchers and also specializes in scaling oversight. And then Faisal Perez, our very own research lead here at Apart Research, who's working with the Apart Lab and also an FLI fellow and PhD student at Oxford. So he is also, I believe, in the Discord, so that is wonderful. And now to the first winners, which are Ingrid, Asta, and Clara. Wonderful. And there is a lot of text on these slides. You can pause if you want to read it all, or jump on the actual link. We'll share these slides as well. But that's $300, the third prize going to them with reverse word wizards, basically looking at a bunch of different phenomena about how different types of models and different scales of models react to the task of reversing words and reversing nonsense words and reversing number strings and so on and so forth. And really, it's super interesting in terms of the methodological approach and being able to cover this broad ground of a bunch of different models and how they react or basically how they work, not how they react. I guess agency is still in the cards for that one. But basically, looking at it as sort of an inverse scaling prize project as well is super interesting, though it doesn't seem to exhibit inverse scaling. But the task itself is very interesting. And so massive congratulations to that team, the reverse word wizards. And the second prize goes to Player of Games. We have great energy in the room here as well with Player. So Player of Games made by Samuel Knoke, and you can maybe correct me there, Sam, who's also with us here. So this is an impressively thorough project, and both Gabriel and Ruki was quite impressed with, looking at this cooperative asymmetric information language game as a proposal for how collaboration and oversight between humans and AI will work in the future, and getting some of these quantitative and qualitative investigations on such benchmarks can really help with understanding how scaled models work and how well we can interface with them in a good way in limited information games, which that's quite useful when trying to understand what's happening within the models. And that's $600, so that's amazing, and congratulations to Sam. And on the first prize, we have automated sandwiching, which is, for anyone who's not, yes, by Sophia and Gabriel. And so Gabriel sharing names with our great keynote speaker as well, who wrote a long text here. And he mentioned that it was exactly the type of project that he sort of hoped would come out of this sort of hackathon, with an actual, automating this scaling and scalable oversight as a really, really good opportunity to understand how we can basically scale it near infinitely, right? If we are able to automate some of these processes we use for scaling oversight, then that's crazy, and we basically win. If we can't, then that's significantly harder. So this is a very good investigation into this, especially for 48 hours. And they also come up, both Sean and Regia come up with a couple different examples of some great additions there. So, for example, adding a bit of prompt engineering to change what the incorrect answer is and so on in the experimental design. But amazing work and really well done. So congratulations to you guys. And then we have the random prize put to a random number generator, and that's $200. And I think just the congratulations to the project Can You Keep a Secret? Exactly. And by Gloria, Clara, and Francisco from us. So that's $200 going their way. And this is, of course, to incentivize some project submissions as well. So thank you for sending it in. And congrats. And now we actually jump to some project presentations. So I think we do have everyone joining here. And whoever wishes to go first can really decide to go first as,
I can go first.
Wonderful. And you can just share your screen or do whatever fits you best regarding project presentations.
I didn't prepare a proper presentation, but can just go a bit through my documents. And I guess the idea is basically to use the evaluate large language models on the Codenames game. In case you don't know, it's basically in the original game you have basically 25 words, and each of them are basically kind of potential code names for spies, and then there are two teams, and each team has a spy master who then has to give like a hint to their teammates to tell which words on this board are like the opponent's spies, and the hint is usually it's just one word plus a number referring to the number of words this hint refers to, and then the teammates then have to guess which words this refers to. And so I end up simplifying this game a bit, just as a one-team cooperative game, using only 15 words that I sampled randomly out of a 400-word group of words that, and then for each 15 words I pick out 5 randomly, and then feed instructions for the game and all the words to the language model, and have it basically play both sides. Here's kind of, I think, the spy master prompt that I use. I explain the game and give like one example and then the list of words, and then ask it to basically give a hint. And I think, and the same thing with the guesser, where I explain the rules. I give a list of words, and then and I also give the hint of the previous model, and then the guesser needs to like give a list of the words which it thinks this hint refers to. And so in kind of the first set of experiments, I'm basically using kind of cooperative. I use kind of 6 of these open large language models available on the OpenAI API, and kind of see how they cooperate on this game. And it seems clearly here this is the accuracy, and clearly I think TextDaVinci 2 and TextDaVinci 3 seem to be clearly actually properly understanding and able to play the game. And yes, interesting how there's, I think, a decent jump in ability between TextDaVinci 1 and 2. And just in case they get like high accuracy by only kind of giving a hint for one word, I also provide kind of the average number of correctly guessed words per game. And then in the second set of experiments, I also kind of play myself as either the guesser or the spy master against the DaVinci 2 and 3. And based on these at least limited results. I seem to be better than the larger language models at guessing the correct words, but slightly worse than Text-DaVinci 2 at giving the hints. Further research is needed, but seems interesting. And then I conclude with some. I connected a bit. I think there's recent interesting results about how this Text-DaVinci 2 and Text-DaVinci 3 seem to be having some theory of mind-like abilities. I think there's a recent research paper. And it might be that this is evidence for a similar thing, because especially if a human is playing, it's kind of interesting where the person who gives the hint then has to really think about whether the associations they have actually would make sense to also to the teammates. And this is fun, and I think this is a good kind of illustration of a potential new class of benchmarks. I think language models have become good enough for proper putting them into situations and having them basically play different language games and with cooperative games with each other. And this seems like probably a more promising avenue for evaluating these kind of models than I think the traditional, which has a fixed group of questions and answers. A few other ideas, but I think that's it.
And I think let's give him a hand for the second prize as well. So congrats to you. I was surprised at the performance of these models, because I know some people who wouldn't reach that performance, right? So this is super interesting, and just fascinating that you can set this up in such a functional way, right? Are there any
one quick point from me? I know we discussed this over the weekend. How do you see this generalizing to, let's say, more games or more domains?
I think you have to come up with a lot more games, I guess. So I think it's I guess in what direction? I think it generalized in the sense. I think it's we can come up with other more different games, more challenging games, and I think this class of benchmark I think is very interesting. And I think this specific benchmark can also be expanded by just adding more words, make it more difficult. I think here I have a more of a limited version of the game. And
well, thank you very much, Sam. Again, I think really nice work. And the next group that we have, at least as confirmed presenters, anyone who are like, hey, oh my god, Espen, I really want to present now, you're also welcome to join afterwards. But we have Gabriel and Sophia who promised to present their projects. So as the number ones, let's give them a little round of applause. Yeah. So you can just share a screen for whoever wishes to do that.
Yeah, I can share the general project idea, and then Gabe can share specifically what we did, kind of. This is from the paper that we found the measuring progress on scalable oversight for large language models. And the general idea here is that you have a non-expert and you have an AI system. And if you can correctly prompt the AI system with the knowledge that the non-expert model overseer has, we can get closer to the knowledge of the domain expert and get more accuracy on questions from the MMLU benchmark, or from that data set with all of the questions. And so that's kind of the general idea, and I think Gabe can share specifically what we did. Yeah.
Yeah, we were looking at that. We were looking at the that sandwiching paradigm I set up in that paper, and we. Did the stream just end? No. Okay. Cool. That the sandwiching paradigm, and we're that Anthropic had done in that paper, and we saw some like points of further exploration. So to recap, they had in this system, they had AIs here, and they had human crowd workers here trying to align the AIs. And then as their domain expert, they relaxed it and they just used the gold labels from some supervised training sets as their like evaluation criteria. So we basically thought like, hey, we could just automate this part too, maybe. Let's see if we can replace this with an AI system. That way we can explore a lot of different techniques for doing this scalable oversight and perhaps more quickly evaluate them. So broadly, the technique we used is we did want the smaller, or like the non-expert to be a smaller model. We wanted to like choose some kinds of tasks that the small expert could not answer on its own, but perhaps by overseeing a stronger model, it could then like get some more information and some more reasoning that could be used to answer the problem. So we used the same MMLU data set from the Anthropic paper, which is one of 2 data sets they used. And basically, most of our work was prompt engineering in being able to craft prompts to have a conversation between these 2 AIs. It was actually quite fun seeing them talk with each other. But basically, all we did was we had a shared conversation that we like prepended human, blah, 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 human asks a question, and then assistant gives some answer, where the human is really completed by the small AI model and the assistant is completed by the larger AI model. We used Curie and DaVinci 003, I believe. And we like passed the conversation back and forth, but we also prepended some instructions for each of the different models in order to elicit them into specific behaviors we wanted. So the small model, we told it, I think we have our instructions here. The small model, we told it it's the human, and it's going to get a question, and that it's supposed to ask some questions to the AI assistant in order to be able to answer those. The large model then was just told you're an assistant and you're going to have a conversation with the human and try to be helpful as possible. And these were secret instructions for the 2 of them. So we'd only like show the small model instructions when it was the small model's turn to complete the conversation, the next like message, and vice versa for the large model. You can imagine it like the 2 models perhaps sitting at a table and passing a piece of paper back and forth. But when they get the paper, there's also like a note card at the top that's secret just for them that tells them what to do. So that's generally what we did, and it worked. It worked all right. There were some subjective instances where we got really cool dialogue. Do you want to talk about some of the dialogue, Sophia?
Yeah, so we had the models talk to each other, and this worked to varying degrees. In some instances, when I think we had the temperature like up for one of the models, they would end up just talking about like irrelevant things or start talking about the weather or kind of like how they were doing, and not talking about the actual question at hand. Another problem we ran into was asking the same question over and over again. And so we ended up, once we used both the 2 models that we ended up going with, we sort of got into a conversation where the small model would ask the big model specifically parts of the question. So like it would ask, what is appeal to ignorance? What is a double negative? As opposed to just asking it random questions. And this is something that we wanted to see from the small model. This shows that it was asking different parts of the question to come up with its own conclusion on how to answer the question. And this was big progress from what we started with. And we anticipate that if we work on the prompt engineering more, we can get it to explain kind of what parts of the answer from the large model it's using to formulate the overall answer to the question, and then choosing a letter that it ends up choosing from the multiple choice.
Yep. So definitely some of this qualitative analysis was encouraging, especially because we compared it to the actual crowd worker conversation logs from some of the appendices of the Anthropic dataset. And sometimes this is how the crowd workers would actually answer, by trying to break up or like ask questions about the different possible answers to the model they had access to. As for actual like performance, then in terms of like absolute performance is actually quite bad. This was on 4-choice question and answer, and these models both got like worse than random accuracy, or these 2 evaluation criteria used. It's actually like not as bad perhaps, because we did penalize models where if they didn't get an answer in time, if they like kept trying to talk for too long, we'd like say it was wrong, or if they did not contain one of the answer choices in their top 5 tokens because of a limitation of the OpenAI API, then we also said that was wrong. But the more encouraging thing here, we weren't trying to get like perfect accuracy with this setup. We were more trying to evaluate, can we use this to test really quickly and evaluate different prompting instructions for these models for how they converse. And you can see there is like a very big qualitative difference between these, where we go, I think this was a 62% change in performance just by tweaking. We added one sentence to the prompt to the small model, where we told it, now instead of doing these things, like try asking the large model for to break up its reasoning step by step, and that ended up making it worse. But anyways, yeah, that was the main contribution of the paper, trying to make an automated system to evaluate different prompting techniques for a small model to get answers from a large model. Broadly, we think there are like some encouraging places people could go from this more. We only evaluated 2 different prompts, and we crafted them very quickly. So there's definitely room to make those better and to just try many more prompts and perhaps have a much more rigorous assessment across many more tasks, perhaps than just one split of MMLU. How well those different prompts work for making the small model able to oversee the large model. There might also be more interesting things we could do with qualitative analysis of these responses, as well as more adversarial prompting. So for example, we told the large model to be helpful. It might be more interesting to tell the large model to technically tell the truth, but be misleading in your reasoning. So that way it's harder for the smaller model to keep up. And that might be a more rigorous test, more high stakes test of some of these scalable oversight proposals. But yeah, that's basically the work we did.
And roll. That's awesome. Let's give them a hand. Amazing. Yeah, I think that project is like super good. And do you think what would be some of the next? I guess you talked a bit about it, but like some of the problems with doing this so focused on prompting, and could we add some different modalities to actually help these overseers in some way or other, or is this just prompt engineering all the way?
Yeah. Do you have an answer for that, Sophia?
I think that there's definitely a ways to go with the initial prompt. I don't think it's reached the best state. I saw in the judge feedback that, for example, when we prompt it for the final answer, we could include a colon and then open parentheses so that it requires the model to fill that in. That might work a little bit better. I also think the language in the prompt can be improved, but beyond that, there are definitely other things that we could do. Seems like, Gabe, do you want to elaborate?
Yeah, because we were kind of evaluating this one modality of scalable oversight that the Anthropic people like defined with like plain model interaction, where one model or human talks to a different model to try to align it. But you could also imagine having some kind of automated debate or market making or critique system here, where a model tries to get multiple models to debate each other, or tries to get a model to critique both sides of its own answers. And so, yeah, I think we'd be excited about work that, not necessarily from us, work that like tries to scale these up and rigorously evaluate how well they work. And if people want to build on this, where did it go? Scale oversight. If I can search. Well, our code is on GitHub. If I can type. So you can. Yes, please take this and fork it and do cool things with it.
Perfect. Yeah, that's a great motivation to just test all the other techniques as well. Awesome stuff. All right.
Sam, I know that you had some thoughts on. I mean, initially you were thinking about sandwiching as well. Is there something that you see in this project that you think you might want to give it a try?
I mean, the only thing that comes to mind that I haven't mentioned is just the idea of using kind of self-play and reinforcement learning to like improve language models, kind of to self-improve. I think there's some recent research that shows that these models can basically create outputs on which then these models can basically improve themselves without any kind of outside help. And yeah, I think one direction I was kind of curious about is what if you use RL to have these language models self-improve on code names, and does this also improve them when they play with humans, or do they start kind of using more like alien concepts and conceptual relationships which humans wouldn't necessarily understand? And I think that's potentially interesting.
Yeah, it seems like that might be a good way to try to forecast how future multipolar scenarios might go. If you do self-play on code names and they start talking gibberish but getting 100% accuracy, that's a little sus.
Right. Yeah. Exactly.
Yeah, you could actually imagine like an interesting AI governance project also being like figure out how these sorts of agents interact with each other in some high stakes, limited information games.
Yeah. Mm-hmm.
Rock and roll. All right, thank you again. Another clap. You know, the more claps you get, the happier everyone is. Clearly. Are there anyone who wishes to present their projects? Otherwise, I will go back to sharing my screen, and hopefully no errors this time. And a massive thank you. I just generated this beautiful little image where the AI says, "Moyo ui nye fu a." So as we all know, that means thank you, everyone, and it's hugging a non-existent human as well. But anyways, a massive thank you goes to, of course, Gabriel Regia, who helped us be a keynote speaker and did an amazing talk, and in general does great research as well on scaling Oversight from a cognitive science perspective, and really interesting to hear his perspective on these things, and also get his judging comments as well. They are really, really good, right? And you can definitely take some inspiration from that. And then we have the jam site organizers, and you know who you are. You are amazing. You are great. We really appreciate you organizing these local events where everyone clearly are happy and having fun. And then Rui Qishang, and again, I hope I pronounced that right, but he was helping us judge these projects as well from Berkeley. This was just from an email thread, and he was just ready for it. So really thank you. Big thank you goes to him. And all you wonderful participants, of course, and the people in this room. And a little clap goes to everyone. So we really appreciate that you want to join and have fun with us, and help us sort of make AI safer and more productive, more positive, more energetic here with hackathons. And then some others, you know, we have Sabrina Saki and Faisal Perez who are helping out, and Sabrina being our community organizer. She's also here, and she's amazing, and she's wonderful, and really making sure a good vibe is on there. So thank you goes to her, and Faisal Perez for leading the research efforts of some of the Part Labs stuff. And then a little thank you goes to some of the Julia Pearson and Giles, who were interacting a lot with GPT-A, our little proprietary chatbot, which is just a prompt engineered GPT-3, right? And having fun with that. And I think Julia Pearson several times bombed Denmark with we're in Midjourney's image generation. So unfortunate, but very fun either way. A little community fun there. Yeah. Otherwise, if there are any questions. This is a great final slide, just a question slide, but I will transition back to Discord. And if anyone has any questions or comments, then now's your chance to bring it both to YouTube, but also here. And otherwise, I will stop the YouTube stream if there's nothing more, and we can all have a little fun. Yes.
Thank you, Esben. You did a great job organizing.
Thank you, and
Esben.
you guys too.